We're going to look in Chapter 7 at the Liskov substitution principle. This is an idea that you should be able to use subtypes the same as you would a general type, and kind of discusses what rules you have to kind of put in place so that this will always work. So the Liskov substitution principle is this collection of guidelines. We'll see down here some contract rules and variance rules. But the main idea is this, and this is kind of written in as a math almost statement, but I'll work you through it. If S is of subtype of T, then objects of type T may be replaced with objects of type S without breaking any of the programs. So for example, if you have an hourly employee class and that's a subtype of the general employee class, then anywhere you have an employee, passing it as a parameter, returning it as an object, you should be able to return an hourly employee, the subtype, instead, without breaking or changing your program. And again, that's kind of one of the basic features of object-oriented programming. But when we're writing code, it is often you're often able to write code that breaks this principle. So we're going to look at some of these guidelines that we're going to look at. So the first thing we're going to look at is contract rules. So when we have a type, we're not going to change. We've got to watch how we change the preconditions and the postconditions and this invariance idea, and we need to talk about what those are. So preconditions can't be strengthened in the subtype, postconditions can't be weakened, and invariance must remain true. And we'll walk through those in just a sec. After we walk through those, we'll talk about these variance rules. This talks about contravariance of the subtypes when we return things, and covariance of that, and we'll walk through that. And in this week's assignment, you'll go through some of this area too. But first, let's talk about a little bit about contracts and how these contract rules work. So contracts are kind of agreements between developers on how code should work. A good example is an interface, and we often say you should be programming to interfaces because that enforces some of this contract stuff. But a more specific version is programmed to contracts, because an interface doesn't define that much. So you might have an interface, and it might define what parameters you're passing in, what methods are defined, what parameters you're passing in, and what the type of parameters passing out. But it's just type specific. It doesn't get into some of the more details. So for example, let's scroll down here and look at the post condition, the precondition one here. Maybe you have a method to calculate the shipping cost, and one of the things you're doing is passing in the weight of the package in kilograms. Well, one of your assumptions is that this weight should be greater than 0. You don't want people to, somehow break the system by buying floating or objects where the weight is less than 0 is negative. That won't work. So that's our assumption here, and that's something that's not covered by this interface. If this were in an interface, you would still be passing in a float, and that would be fine. So what we often do in our programs, we might right away write an if-then statement. If the package weight is less than some 0, we throw some exceptions. So that's one way of kind of manually enforcing these contract. And the book walks you through some other ways of doing this, defining a special exception and how that would work, how you define that, and working on. Similarly, here we're checking the size, the dimension of the package if it's less than 0 in the X or Y direction, and again throwing some exceptions. So exceptions are one way of handling this sort of process. And then the idea of this is that, let's go back up here to the principle, preconditions cannot be strengthened in the subtype. So if you have a generic package here, and in a generic package the package weight has to be greater than 0, you can't have a subtype, let's call it a big package, where the weight has to be more than 10 kilograms. That breaks this rule. So all your subtypes, if you have contracts or if you have specified preconditions, they have to hold for all of the subtypes as we go. and so that otherwise, again, if you have a certain type, so if you have a precondition, you can't strengthen it in a subtype. If you do, that means that the subtype can't always be substituted for the main type without breaking the program in some ways. Similarly with post conditions can't be returned. And again, we can follow those post conditions in a similar format. We can maybe we do some calculations at the end. We're returning the shipping cost, and again, we want to make sure the shipping cost is more than zero. So we're checking if the shipping cost is greater than zero, and if not, we're throwing an exception. And again, you can't have you can't loosen those conditions for this. So next example, we say the shipping cost must be greater than or equal. Must be greater than zero. If it's less than or equal to zero, we throw an exception. So you might have another package, a free package or something like that, where the shipping cost is zero, and that would break it. That would loosen these post conditions and break it. So when you define your pre and post conditions, your contracts, you want to make sure they apply to the parent class and all the child classes. If not, you don't want to be throwing these sorts of exceptions. You want to handle it in some other format so it doesn't break the program by throwing exceptions. Similarly, for invariance, if you're saying that some inside a method, some parameter or some value is not changing in the parent class, you can't change it in a child class also. So in variance, we can't change a parameter or value if it doesn't change in the parent. If it's specified that it won't change in the parent class, we have to follow that invariance rule in the child class. I should note that now we call these data contracts, and we have them specified here using these if, then, and throwing exceptions, but they're actually more formalized ways of doing contracts. In the book here, I link to the Wikipedia article on contracts and how they're set up. Different languages have different supports for those, and we're not going to go, C# does support those, but we're not going to go into too much detail of those. So there's a section of your text here that deals with code contracts and talks about that, working with them in the .NET framework. And so rather than specifying those exceptions, whatever, you can actually use code contracts and specify rules for them. But again, we're not going to go over and set up those code contracts. But at times you'll see those code contracts set up in particularly when you do the final project. If you do the code that's in here, we'll run into actually some problems with the code contracts and how those are set up. So these are just a way of setting up these rules rather than manually setting an if then and throwing exceptions. This is something very similar, but in a more formalized setting. So, and most languages have those contracts. And some companies use those, some companies use the more informal methods of doing that. Okay, so then the next thing we're going to look at, okay, so we looked at these rules for precondition, post, and invariance. Now there's these variance rules that talk about contravariance and covariance, and let's just talk about those a little bit. So with covariance and contravariance, they're really more complicated words for relatively simple principles, and that's basically that you should be able to substitute a subtype for a parent type or a parent type for a subtype. Don't think your textbook does a great job of defining those, so I'll walk you through these. So the idea is that you have, let's say, a supertype and then a subtype here. So covariance means that you should be able to use this subtype in place of the supertype wherever it's needed. So let's walk through an example of that. So let's say we have an entity as our generic type, and a more specific version is a user. So the user is a subtype of this entity type. And so we have an entity has a ID number and a name, and users also have an email address and a date of birth. And then we're going to look at so here's the definitions of an entity, and a user inherits from entity and adds again the email address and the date of birth. So now we're going to use a repository pattern. We're going to use a method that's just going to go out, get an entity and return it, or get a user and return it. So we're given the ID number of a user or an entity and we return it. So maybe we're going out grabbing it from an array, or maybe we have to go out to some sort of database and get those. We're not quite sure, but that's what the repository hides, that complicated stuff from us. So here we have a virtual function called getID that's getting the ID. And then we have a more specific one in user. The user repository it inherits from this entity repository, and it returns a user ID. And so, but we'll run into some problems here because when we can use this more specific type in here to do things, and so run into some errors with this. So in this week's assignment, where I'm going to walk you through, you're going to walk through this code and look at how to fix these errors with this. Now, similarly, there are times where you want to use a more generic type, particularly like when you're maybe returning a value or passing it in as a parameter. And so contravariance is a similar idea. So where covariance relates to the treatment of types that are used in return values, contravariance returns to the parameters themselves. And so where we want to be able to return the more generic types at times, we also want to be able to pass in the parent types at times. In here I also linked into a little bit of definition at Microsoft's development network, defining what contravariance and covariance are, and gives a simple example of this. Again, I often find the wordings of this difficult. That's why we're going to try to do this in this week's assignment. So we'll walk you through that a little bit more when we get to the assignment.